let's look at a couple of patterns and use inductive reasoning to see if we can figure out what should be next. Now, it seems like this is deductive reasoning, right? Because we're looking at it, we're like, oh, this is what has to be next. But in any pattern, all we can do is guess and hope that we're thinking the same pattern that someone else is. I have a friend who hates questions like this. He teaches math, he just says, no, I don't think that looking at patterns in this way makes sense to do because it could be anything next. Regardless, we have to do it, we want to know how to do it. So let's look at a pattern. Here's my first pattern. I've got 4, 7, 10, 13, 16. Now, whenever I first look at a pattern, I always try to do as little work as possible. And if it looks like it might be the thing, I'm going to say to myself, hey, what could I add or subtract to get from one of these to the next? So if I look from 4 to 7, it looks like I'm adding 3. So I say, okay, what about from 7 to 10? Oh yeah, it looks like I'm adding 3 there too. From 10 to 13, adding 3. From 13 to 16, adding 3. Since what I came up with seems to work for every one of these steps, I'm going to say that if I add 3 to 16, I'll get 19, and that must be the next number. That must be the pattern that's happening here. Now, like I said, that doesn't have to be the pattern that's happening here, but it works for all my guys. It works for each one of these steps. So that is enough for me to say, yep, my inductive reasoning tells me that must be the thing. Now let's look at this next guy. So this time I have 3, 6, 12, 24, 48. So 3, 6, 12, 24, 48. Now I can see that these aren't all going up by the same amount. Right here, if I add 3, here I have to add 6, here I have to add 12. Like I'm not going up by a constant amount. However, if I look at that, here I guess I add 24. So it looks like I'm adding the number to itself. That's not the pattern I was thinking of. I was thinking of multiplying by 2. But that gives me the same effect. Either way here, if I add 48 to this or multiply it by 2, the next number here is going to be, let's see, 40 plus 40 is 80, 8 plus 8 is 16, 80 plus 16 is 96. So those two different ways of looking at this pattern will both give me the same next number. So that's probably it, right? That's what I'm hopeful that someone, whoever came up with this pattern was thinking of, is 96. Okay, let's look at our next one here. This time I've got 2, 3, 5, 7, 11, 13, 17, 19, 23, 29. It's an awful lot of numbers, but let's just get down to it here and see if we can notice anything. Let's just start with these guys. So if I look at just addition, I've got 1, 2, 2, 4, 2, 4, 17 to 19 is 2, 19 to 23 is 4, 23 to 29 is 6. That doesn't look right. It doesn't look like that's getting me a pattern, at least not on an initial try. If I was looking at this for, 10, 15 minutes and I couldn't come up with anything else, I'd say, yeah, well, maybe there is something to that, and I'd go back to it. So, but for right now, maybe there's something else. 2 to 3. Let's see, that's multiplication by 3 halves. 3 to 5, that's multiplication by 5 thirds. 5 to 7, that's multiplication by 7 fifths. 7 to 11, that's multiplication by 11 sevenths. Yeah, that's really just telling me the pattern is the numerator and the denominator. I don't think that's what we're up to here either. All right. Now, unfortunately, let me give you one more technique you can try for just any random one. Sometimes it's helpful to look at every other item as separate things. So if I look at this pattern of 2, 5, 11, 17, or I look at the pattern of 3, 7, 13, 19, sometimes I can find a pattern there, and I've just got two patterns going on instead of one. So that's another avenue to try if you are not sure. But this pattern isn't any of those. And in fact, to know what this pattern is or what the next number is, you need some little piece of trivia. This happens to be a list of prime numbers in order, starting with 2. So if you recall, a prime number is one whose only it's a whole number greater than 1 whose only divisors are 1 and itself. So this is a list of primes: 2, 3, 5, 7, 11, 13. Notice, for example, 4 is not in there because it's 2 times 2. 6 isn't in there because it's 2 times 3. 8 isn't in there because it's 2 times 4. 9 isn't in there because it's 3 times 3. 10 isn't in there because it's 2 times 5, etc. So I just need the next number like that. 30 is divisible by 2. It's 2 times 15, so 30 is not prime. But 31 happens to be prime. So 31 is the next number here. That one's pretty tricky because, like I say, it requires some outside knowledge. It's not something you can just look at and know. You have to have that other piece of knowledge. All right, I just want to look at one more here. This time I've got 1. Whoa, I want to be writing in black here. 1, 1, 2, 3, 5, 8, 13, 21. So if I look at this guy, let's see, adding 0, adding 1, adding 1, adding 2, adding 3, adding 5, adding 8. Now again, addition kind of gives me that hint as to what's going on here. If you look at that pattern and you look at these guys except for the 0, notice that there's a 1, there's another 1, there's a 2, there's a 3, there's a 5, there's an 8. Each one of these guys is repeating the pattern above it. So what it appears like is that I add the number that I just had to the number that I have now, and I'll get the next one. So here to 21, I should add 13, gives me 40. No, it doesn't. 2 plus 1 is 3, gives me 34. This is in fact called a Fibonacci sequence, and it's usually defined like this. Start with 2 numbers, and then the next number is what you get from adding those 2 together. So 1 plus 1 gives me 2, and then 1 plus 2 gives me 3, and I'm almost out of colors here. 2 plus 3 gives me 5. That makes this guy a Fibonacci sequence, but just by looking at that addition, we get the right idea. We can find the next number in the pattern, even if it's not the same reason as why someone else got that number. Sorry, that one was a little long, but thanks for sticking with it.